So this is post-lunch session, so I'm going to try to bring some energy to the room to keep us all awake and invigorated. This talk is Revoke-Obfuscation, detecting obfuscated PowerShell using science. I don't know about you, but I've learned so much already from a day and a half of this conference, and some of the things that get me most excited are seeing different syntaxes that people are using in their demos that I've never seen before. It's really cool. Like, has anyone learned a new syntax for something they do all the time? Anybody? Awesome. So I hope that you'll learn some new syntax from this, although you may not find it useful in your day-to-day, because I'm approaching this topic from the perspective of how do we detect attackers who obfuscate PowerShell code to try to evade detections that we as defenders put in place. So this is some research that I did last year, started last year with Lee Holmes from Microsoft, one of the original PowerShell developers. So I learned a ton about PowerShell with working with Lee. So he's with Microsoft, I'm with FireEye, and I do applied security research. Before that, I did incident response consulting, and I've written a few obfuscation frameworks that we'll very briefly talk about today. So the agenda. First, just a quick kind of high level, like what kind of proper logging do we recommend to our clients and organizations to have in place to investigate when attackers might use PowerShell maliciously? And then we're going to just go through a really fast, deep dive crash course of obfuscation that you can do with PowerShell. And then we're going to look at the science part of it. How can we detect this crazy obfuscation? And then we'll do a demo of the tool that Lee and I developed called Revoke-Obfuscation. So this talk is really a treatise on blue team follies. So Lee and I both are defenders. Even though a lot of this research I've done is more offensive in nature, it's always for the purpose of better understanding what is possible with the language so that we can better defend things that we've never seen before. All right. That button got stuck. Let me rewind a second. So preparing your environment. PowerShell's logging is just insanely cool. Script block logging, module logging, transcription logging. A lot of environments just don't have it enabled because they don't know about it, or it's too hard, or they don't know what to do with all the data that comes back. And this project was really, we wanted it to be usable for defenders from day one so that they could actually do something meaningful with all these insane levels of logging that PowerShell provides. In addition, kind of at a bare minimum, is we recommend clients have process level auditing with command line arguments. And so a lot of the stuff we'll look at today doesn't have so much to do necessarily with interactive PowerShell usage, but looking for, well, what are the things that attackers do when they're first trying to compromise a system using PowerShell. So, launch techniques. What are some of the ways we see attackers launching PowerShell that first time to get that foothold on the system? Well, in this case, our malicious command is just the simple write host, right? Typically, we see attackers launch PowerShell and then -command, -c, something like that, and then the actual PowerShell command. And usually it's to download some remote script. However, if you look at PowerShell's help, it's kind of the best in the business. It conveniently says, you know, if you just end your command with a dash on the command line, then we'll run whatever you pass in as standard input. Now, that's really cool for a couple of reasons. If I'm an attacker, that means I can actually just echo my PowerShell command into PowerShell, PowerShell dash, or PowerShell IEX input, and it will run the code just fine. But as a defender, if I'm only looking at PowerShell.exe executions, then the only thing I see in the arguments is a dash or IEX input. I have no clue what command was run. And if I don't have PowerShell logs, then I really have no clue what was run. The actual meat of the command is in the parent process. So clever attackers will start to kind of separate the artifacts in a lot of different places to make it really difficult for us as defenders to have all the pieces of the puzzle that we need to figure out what happened. So maybe as defenders we say, okay, if we look at this example, maybe we just want to look for any arguments that contain pipe and then PowerShell. Well, unfortunately, you can use command level obfuscation and chop up PowerShell into two pieces. In this case, we're setting it in P1 and P2. And then on the command line, all we see is %P1%, %P2%. So, okay, that kind of stinks. And attackers are using these techniques. This is a financial threat actor called Fin8, and this is from an obfuscated macro. And basically, they set their PowerShell command in several environment variables, and this bottom is the actual PowerShell command, the final one they want to run. And they stored it in this environment variable Microsoft Update Catalog, and then in Microsoft Update Service, they store this string PowerShell dash. So the only thing you see the windward launching is command echo var1 pipe var2. All the other details are in memory, also in PowerShell logging. And if you notice the shield up here, whenever the shield is on a slide, it's basically saying this will evade a lot of detections, but PowerShell logging still captures all the data. It may just be in several places, and you have to reassemble it to get the full picture of what happened. So another thing that we could do, and attackers do this quite a lot, is they'll just store their command in a parent process, setting it in an environment variable, and then just launch PowerShell to invoke the contents of some, let's say, randomly named environment variable. A lot of times they'll store the command in registry. You could also pipe your output into the clipboard and then use .NET to retrieve the contents out of the clipboard and then execute it. So there's a lot of ways that attackers could try to evade detections here. So maybe we should just say, okay, instead of only looking for PowerShell.exe executions, maybe we should look for PowerShell and also any parent process of PowerShell, and then look for kind of malicious PowerShell strings like download string, new object, net.web client, some of the things that we see attackers use a lot. However, there are ways around that. So that would work in this case where we have command echoing the command to PowerShell. But what if we added a second command in there? What if the first command set the PowerShell command in a variable, and then it spawned a second command that echoed that variable into PowerShell, and PowerShell runs as a third command? If we run this command, technically the code executes, but we still see the full command in the parent process. So as an attacker, we could do better than this, right? What if we escape this vertical pipe, but with one layer of escaping? In this case, we're escaping it for the first command, but not escaping it for the second command. Now, if we do that, what's going to happen is our parent process is not going to contain the PowerShell command either. It's going to be up into the grandparent process. And this is just kind of a tree representation of that. So now as a defender, maybe just looking at PowerShell and its parent process isn't enough. Maybe we need to recursively go up. The only problem with that is that you can actually pass data back and forth with no shared process. The clipboard is one example of that. You can have two completely unrelated processes piping, and the clipboard is kind of the commonality. We've seen some attackers do some interesting things with spawning processes and naming the command prompts with code in the names, and then using WMI to reassemble all that into a single string and then invoking the expression. So the good news, and again, it's awesome. I'm preaching to the choir here because PowerShell logging is so awesome. And as an evangelist of that logging, a lot of clients just aren't aware of how good this logging is. The bad news is that there's a kind of obfuscation that the PowerShell script block logs don't deobfuscate. So let's look at that. And for this, I'm going to use this terminology, the cradle, or the download cradle. What do I mean by that? Well, the download cradle is this kind of one-liner remote download script. Right? This command that will download into memory a remote PowerShell script and invoke it. And these Veil, PowerSploit, Metasploit, these are some of the more well-known offensive free open source frameworks that will generate payloads that look like this. So we see attackers using this all the time. Really good attackers, really bad attackers, everybody, because copy and paste is really easy for this one-liner. So let's say that we have this attacker command at the top. New object, net.web client, download string, this totally legit bit.ly link, I promise. Downloads that into memory and then invokes it. So let's say that we're all defenders here. And if we see this on the command line or in script block log, what are things that we could key off of to detect if this runs on any system in our environment? Because I want to know when this happens. Well, we could say, okay, if I see invoke expression, if I see new object, system.net.web client, and .download string HTTP, would that catch this command? It would. Awesome. So now, let's see why assumptions are dangerous here. If I'm an attacker and I know that this defender is detecting me in this way, how can I try to evade it? This button is getting stuck. So one thing we can do is we can start removing system dot. Anytime you see system dot, it's not necessarily PowerShell will automatically add that in. So if an attacker doesn't have to have system dot, then as a defender, I don't want to rely on it being there in my defense. So I'm going to remove it from the command as the attacker and remove it from the strings as a defender. Next, HTTP. Well, if we look at this as tokens, this is just a string. So An attacker could just concatenate it like that, easy. So maybe we don't want to have HTTP in our detection there. In addition, you could also use single quotes, double quotes, white space. You could set it as a variable before. There's a lot of things you could do there. Download string. Download string is the most common method that we see for this class, that we see attackers using, but it's not the only one. Download string, download file, download data. We've seen all of these used maliciously. So maybe we should just cut our detection short and say .download to kind of cover all these bases. Perfect. Now, how might this parenthesis actually not be necessary? Parenthesis .download. Well, for new object.net.web client, we could always set that in a variable and then say variable name .download string. And there are some frameworks that do just this. So let's remove that parenthesis from our detection. So we're stuck with .download. However, how can we, given any arbitrary member token, how can we obfuscate that? Well, what I found out is that given this member token, you can actually put single quotes around it and it runs perfectly fine. So now that dot isn't even reliable. We can also put double quotes around it. And if you look really closely at download string, I promise this next slide actually works, but you can actually put a tick mark in front of it and it runs. Now, why is this? Well, the tick mark obviously is the escape character, right? So as long as it's escaping something, however, that's not 0, A, B, F, N, R, T, V, and I think, is it X or U? PowerShell 6 introduced one more character. If it's escaping something that has no escapable meaning, then it does nothing, and the command runs fine. But the problem is that those tick marks stay in script block logs and command line argument logging. So we can put tick marks in front of any characters that doesn't have escapable meaning. But if we really want to put tick marks in front of those escapable characters, all we have to do is uppercase the characters, and then we can put tick marks in front of it. So now any character we want, in any member, we just put double quotes and put tick marks anywhere we want. This is getting really hard from a defender's perspective. How do we detect this? Some crazy regexes? You could. I wouldn't recommend it, because we'll look at some stuff later. But basically, as you can see, in command line argument logging and in the deepest script block logs, these ticks are still there. So let's keep going. I feel like someone's playing with some RF signals here. If you wouldn't mind holding off on that, then I'd appreciate it. So another method is the open read method that we do see attackers use sometime as well. All right, this is okay. So we can also wrap a member with parentheses and then treat it as a full-blown string and do concatenations, reordering, etc. And if you're using PowerShell 2, you need to add that .invoke, but with PowerShell 3 or later, you definitely don't have to do that. So let's just remove the .download from our detections. Net.web client, with this, we could just put tick marks in front of it. We could encapsulate it and concatenate it. We can chunk it up into little variables, etc. So basically, we can't really rely on net.web client being in that form either. So we'll just choose that option. New object. Now, PowerShell is awesome. I actually accidentally happened into PowerShell because I was writing batch files, super sophisticated, right? And my friend said, why don't you just change the extension to .ps1, and it will probably actually work. And then you can start one by one introducing little snippets of PowerShell. And that's how I started doing PowerShell. And so PowerShell has such rich aliases that are really helpful. If you come from a Linux background, you can still use ls. If you come from command prompt, you can do dir, or you can use get child item, or GCI, or even just child item. Crazy, right? PowerShell is really helpful. So as a defender, though, when something's really helpful, I have to take all those options into consideration when I'm writing detections. The good thing is that new object doesn't have any aliases, so I thought, sweet, this is going to be a really good detection. Not so fast. PowerShell is really helpful. Since there are so many commandlets and functions and aliases, you can just say, hey, get command, let me see what I have. And you could say, you know, I know that there's this commandlet that's new-p something. So I can just say get command new-p star, and it shows me all the matching commandlets. What's interesting, though, is that if we return a single commandlet, we can invoke it as an object or a string. So in this case, we use invoke expression, and we're invoking it after it's cast to a string. But we could also use, come on, keyboard. We can also use a dot or an ampersand to invoke it. And then if you notice, as the keyboard so politely jumped ahead 10 slides, we can start to introduce wildcards. And as long as we're returning just a single object, we can invoke it. So now this is new object. Each of these are. This is what it looks like on the command line. This is what it looks like in script block logs. In addition, get command has an alias of GCM. Great. Let's remember that as well. There's also an undocumented alias of command. So anytime PowerShell has a get dash in front of a commandlet, you don't have to actually say get dash. It will automatically prepend that and see if there's a commandlet that matches that. Sweet, maybe? Yeah, it's good for usability. It really makes it more difficult to detect. There's also a lot of PowerShell 1.0 syntaxes that you can use. The execution context.invoke command, get commandlets, etc. All these crazy things that you can do. In addition to get command, you can do the exact same thing with get alias. Instead of dealing with a full commandlet name, you're dealing with an alias name. So now we have all the get command stuff, all the PowerShell 1.0 stuff. Then we have get alias. We have gal, which is the alias of get alias. And then we have alias, which is the alias of get alias. Crazy, right? Ugh. Man, my head's spinning. Okay, let's just choose one of those options for new object and say, you know what? Let's just give up on new object. Let's let that go. Now we're left with invoke expression. Well, it's actually a good indicator, but it's not the only way to do it. Another thing we can do for any commandlet is we can also just piece together the string of the commandlet name and invoke it with the invocation operator. With concatenation, reordering, using the format operator, crazy stuff you can do. So invoke expression, what do we need to know about this from a defender's perspective? Even though invoke expression has its alias of IEX, which is more commonly used, there's also tick marks for any commandlet. We can concatenate it as a string and invoke it with the dot or the ampersand. Fun fact, I'll talk about in a second on the more science part of this, is Lee Holmes and I assembled this massive corpus of PowerShell scripts from these public repositories, and about 3% of the scripts in the wild used invoke expression, which actually doesn't seem like a big number, but then if you think about, could we actually remove this functionality from scripts? And the answer is no, because that's a lot of scripts. We assembled over 400,000 PowerShell scripts, and 3% is a huge number still. So in addition to invoke expression, we have invoke command. Come on. Now typically invoke command will be used to run script lock on a remote system, but if you just don't specify a remote system, it runs locally. So some different syntaxes for invoke command. You have its alias of ICM. You can invoke a script block with a dot or ampersand. You can add dot invoke at the end. Invoke return as is. If you're 3.0 and later, you can do invoke with context. There's more and more and more options. In addition to PowerShell 1.0, you can do invoke command, invoke script, and pass it either a script block or an expression. That works as well. You can add in ticks to all that if you want. When it comes to ampersands and dots, how can I, as a defender, reasonably expect to alert anytime I see an ampersand or a dot? It's impossible. But maybe if I'm invoking a script block with an ampersand or a dot, I can only alert if I see an ampersand or a dot and open and close curly braces, because that's the only way you can define a script block. Or wait, is it? No. Actually, we can convert an expression to a script block. Here are just two ways to do it, using the script block create as well as new script block. And for each of those syntaxes, you can apply all the obfuscation we just talked about and get something that looks like that. Great. There's really no good solution here. A tool I released last year called Invoke Cradlecrafter actually makes this really easy to explore all these crazy invocation syntaxes just at a click of a button. All right, let's just breathe for a second. That was a lot. The good news is that's really the extent of obfuscation when it comes to PowerShell. No, I'm just kidding. There's a lot more you can do. After this, we can take our command, treat the whole thing as a string, and then apply string layer obfuscation. So we can take our full command and just reverse it, and in memory it will be reversed before it's invoked. We could split the string by putting all these garbage characters in there and then split and rejoin on nothing, and our command is reassembled back in memory. We can replace stuff. We can concatenate stuff. Come on. The good news is that for all these extra layers, they'll all be resolved in script block logs. But all the token stuff we just talked about, all the tick marks, the concatenation, all this stuff, as long as it's not being passed into an invoke expression or invoke command, it's not deobfuscated in the script block log. So we have to still realize that data is going to be obfuscated when we're writing our detections. So, Invoke Obfuscation was the first framework that I released a year and a half ago to basically take any arbitrary PowerShell command or script and allow you to systematically obfuscate all these different things. So you can take this simple download cradle as an input and then produce something like this, just with a single click. You can then wrap it one more time in something like this. And there's a threat group known as APT32 out of Vietnam, and they love using my tool for this, and they wrap it in about 7 or 8 layers of obfuscation, which gets really crazy. And you best believe that when other consultants find my tool being used, they always send those samples to me for me to deobfuscate. So, yeah. That's fun. Invoke Cradlecrafter, which is the second tool I released, you can basically input just a URL, and it uses a completely different kind of obfuscation. It will use substitution obfuscation. So remember how we had download string and we were basically adding like tick marks or concatenating? Well, what this will do is it will say, let me just create a new object net.web client, and like the 37th element is download string, so let me get the name for that, and let me obfuscate every little piece along the way. And so download string is now like 150 characters long in all these nested commands, and then you just plug that right into the command. So this is that download cradle. A researcher in 2010 wrote Hello World with PowerShell using nothing but special characters. So I extended that technique. So basically, any input command can be written 100% in special characters. And that's just a ton of variables. It's really brilliant the way that he did this. But since those are all variables using special characters, you could also just make the variables be different amounts of white space. So there's like 12 or 13 variables in there. And then I was talking to another researcher, and he gave me this idea of using, well, it's not my idea. He mentioned this concept that's been done before of using white space encoding. So I put that in there as well. So the whole command starts with a single quote all the way down, and it's white space delimited by tabs, or tabs delimited by white space, and the stub at the end will reassemble it. So as defenders, we're feeling really good, right? No, this sucks. This is terrible. Like, Daniel, why did you do this? Like, I thought you were one of us. Why are you making our lives miserable? I guess curiosity. So can we be more intelligent about detecting this? We can definitely get some wins if we're using content matching or regex or something like that, but it's really expensive, and it becomes very challenging to detect things we've never seen before. Now, as humans, if we look at these scripts, nothing in our gut says, yeah, let that on through. That's okay to run in my environment. No. Viscerally, we're just like, oh, that looks so bad. That's wrong. This script analyzer would not be happy about this. This is evil. How do we quantify this, though, for a system to say this is not good? So Lee Holmes, after I released the first obfuscation framework, he wrote this blog post, and he did this really cool exercise. He took Poshcode, which is a public PowerShell sharing platform, and he gathered at the time 3,400 scripts, all the scripts off of Poshcode, and he did character frequency analysis. So on the right side here, the average characters in all of these PowerShell scripts, you know, E, T, A, R, it's all alpha characters. The $sign is at 3%. That's the highest one. Well, on the left, we see those two crazy scripts that are all these special characters. 20% of the script is a quote, 20 is a $sign. Like that's very clearly different than the average. So this is the nerdiest slide, I promise. Cosine Similarity. So what we can do is, if we have 2 points on a line, then with a cosine, we can say, is this line very similar to this line, or are they very different? Now, we can extend that concept to beyond 2 points on a line, 3 points, 4 points. Maybe if we're doing alphanumerics, we could extend it to 36 points, and then see how similar are these frequency analyses. So that's what we did. Now, if you look here, most of the scripts are very, very close to 1. The values are between 0 and 1. Most of them are like 98%, 95%, maybe even 90%. These two are 15% and 37%. That's crazily different. So if we take all the scripts in Poshcode and plot it out, this is what we get. Most of the scripts are very close to 1. But then we have these outliers way down here. So if you told me, Daniel, you have to look at 36 or 3,400 scripts and find all the obfuscated ones, that's going to be a really boring weekend for me. Or I could take a quick approach and say, well, let me just take all the ones that fall under 80%. Now I'm just looking at 100 scripts. That's much more doable for a quick win. However, the problem is we don't know, did we miss any obfuscated scripts that are way up there hiding with the rest of the good scripts? So 2 years ago, Microsoft ran a little contest called Underhanded PowerShell, where they invited the community to submit underhanded, obfuscated, just crazy ways of performing a very simple, defined task to try to evade detections that were in place. But we really needed a lot more data than that. So we started gathering all the scripts we could find out of public repositories. They're listed here. But we did it politely. Now, why do I need to say this? Lee wrote this script, and you don't have to read it, obviously it's very small, but the blue portions in here are the code that actually scraped, in this case, all the files from GitHub. And the red portions are 100% Canadian. Because Lee is Canadian and he's so polite, and it was like throttling, making sure he wasn't like taking up too much traffic. It was awesome. At the end of the day, this process ran for weeks and weeks and weeks and weeks, and we're like, man, time's a ticking. We need this data to research. And so it ends up the most polite thing you can do is just to call up or tweet the good folks at GitHub and say, hey, can you just like run a query and give us all the PowerShell, the public PowerShell scripts? And so over a lunch break, that's exactly what they did. So kudos to them for helping out with that. And a really big kudos to everyone who's ever contributed a PowerShell project to GitHub, TechNet, all these different places, but PowerShell Gallery. So I won't take the time to read this just yet, but if you have ever contributed, actually, if you wouldn't mind raising your hand if you've ever contributed a PowerShell script or module to any of those sources. Would you mind raising your hand? Can you give yourselves a hand? Because you made this research possible. Seriously, thank you. So now, when you assemble all these scripts, you actually have to look at them to do something meaningful with them, right? And you find some scary stuff sometimes. You also find some funny stuff. So one of my favorites is this one, remove games.ps1. Someone really didn't want their employees playing games, which I can understand that. But to actually, like, what if they actually remove the high scores? Like, man, that's really sad. Buzzkill. But at the end of the day, going back to all seriousness, we assembled 408,000 PowerShell scripts from over 28,000 authors. And over several weekends, we labeled manually 7,000 of these scripts. Now, why is it important that we labeled them? We labeled them as obfuscated or clean. That's important because if you think back to this, if we only look at the ones below 80%, then we can figure out how accurate this approach is. But we have no idea about the remaining 3,300 scripts above 80%. So what we do is we manually label a subset of this huge corpus, and then we use that labeled data, which is just saying this file is clean, this file is clean, this file is obfuscated, and we're going to use that in the next slides. So again, looking at this graph, if we go above 80%, then we will find more obfuscated scripts, but we're going to have a lot more clean scripts that we have to look through. The false positive rate is going to climb significantly. So the data science community has a couple terms they use to basically talk about how accurate a model is. The two ones that I want to point out are precision and recall, and they're combined to form this F1 score. But just think of it this way. Precision, if we have 100,000 scripts, and 10% of them, 10,000 are obfuscated. Let's say our model says, of the 100,000 scripts, I found all the obfuscated ones, and it's these 1,000, just 1,000. Let's say every single one of those was truly obfuscated. Then our model would have perfect precision. Whenever it says something's obfuscated, you can believe it's obfuscated. It would be 100%. But the recall would only be 10% because it said of the 100,000, these 1,000 are obfuscated, but it missed 9,000. So when we're looking at these models, we have to weigh both of those numbers. So this character frequency analysis over the whole script was almost 90% precision. That's really cool. But 37% recall, it didn't even find half of the obfuscated scripts. This is PowerShell. We have power at our fingertips. We can do better. So what else do we have at our fingertips? Well, we have the language tokenizer, so we can see, parse any command or script and find all the elements and all the tokens. But the really sexy power that we have at our fingertips is the abstract syntax tree. This is the coolest thing ever, and PowerShell makes it so easy to access the AST. Not only does this tell us what the tokens are, it also gives us the relationship of those tokens. Now, what can we do with that? Fun fact, the PowerShell AST, or Show PS AST Viewer is a really cool module you can use just to paste in PowerShell code and actually explore the AST. So, really nice way to kind of explore it. So what we did is, instead of just saying we want to apply character frequency analysis to the whole script, we intelligently said, I want to do character frequency analysis just on commands. And then I want to do it again just on strings. And then I want to do it again just on functions, or just on variables. And not only do we do character frequency analysis, we also do entropy, We do length, max, min, median, mode, range. We do white space density, character casing density. Some obfuscation frameworks will randomly do the case. We do all that kind of stuff. We also do entire groupings of, hey, 80% of this PowerShell script is variables. Is that weird? I don't know, maybe, but we capture all that data. So for any input PowerShell script or command, we extract 4,998 features. And again, when I say features, it's literally just variables, the percentage of variable characters that are the letter A, percent, that are the letter B, percent. Like, it's just this huge CSV of numbers. And those are all our points, like this crazy 5,000 dimensional line. So now, how do we actually determine which of these features is more important to detect if a script is obfuscated? Well, Lee and I could sit around and say, hey, do you think A's are really important for detecting obfuscation? I could be like, I don't know, maybe, let's try. Well, that's a really dumb way to try to do it because there's 5,000 features, and I don't even know what half these features are because it's so much data to wrap your head around. So a more intelligent way let me back up. The way we're using these features is basically every single feature has a weight to say how important it is for detecting obfuscation. And then anytime we receive a script, we extract all 5,000 features, and then we multiply it by the weight to be like, how important are you? And at the end, we add those values up and say, are you obfuscated? Are you not obfuscated? So the second nerdiest slide is this logistic regression slide. Basically, think of it this way. We have a lot of values that we're extracting as features, and some of those values could be like 0.5 or 0.3. Other values could be like, hey, the average size of this array is 10,000. Well, that's really going to mess up our numbers if we have this huge range. So we use this logit function to say, take all of our values and smash them between 0 and 1. Makes it a lot easier to work with. And then what we do is we calculate. We basically take those labeled data and we run them. And we basically say, extract the features, and our model will say, okay, I think this is obfuscated. And since it's labeled data, we can say, hey, was the model correct? If it was, perfect. Let's move on to the next script. If the model was wrong, then the model will say, okay, which of the features had the highest value? As in, I was wrong. Which features did I believe too much that led me to be wrong? And then adjust those down accordingly. And we do this hundreds and hundreds and thousands of times. And as you'll see, our arrow pointing to the center slowly gets better and better, more and more accurate. And it's doing that because it's learning which features are the most important at saying this is obfuscated versus not obfuscated. So think back real quick. When we did the cosine similarity with just the character frequency analysis of the whole script, we had 89% precision, 37% recall. With this new linear regression, 96% precision and 94% recall, and we cut our false positive rate in half. So with the AST, we just got 10 times better at finding obfuscated commands and scripts with half the false positives. We were excited about this. So you may ask, well, what about sketchy stuff, right? Like, there are some things I look at and I can say, okay, this is obviously not some crazy obfuscation produced by some framework like this thing on the left. But what about the thing on the right? I don't know, at a quick glance, I would take a second look at it. The kind of, what Lee and I said is, if we had an intern who was going around and trying to find obfuscated scripts, would we be happy if that intern brought us this script and said, hey, would you mind taking a second look? And that's the whole point of this. If we have thousands and thousands of script blocks in our environment, we can only look at a limited number of them. So how can we intelligently filter down from thousands of scripts, maybe to just 20, and look through those? So we added this kind of sketchy option, right? And we call it deep inspection, which means you should run the high fidelity one first. Those are your quick wins. But then after that, maybe you want to look a little deeper and say, you know what, I'm willing to look at 20, 30, 40, scripts that are actually clean, but if it'll help me find more obfuscated scripts, I want to do that next. And so in this case, our false positives definitely increased up to 5%, but we went from 88% recall to 97% recall. That means out of 100 obfuscated scripts, we're leaving 3 on the table that we didn't detect. So with this labeled data, Lee also took it and put it into Azure Machine Learning Studio and just tried some different models. There's again, Lee and I, neither of us are data scientists, but there's entire communities that just nerd out about this stuff and do really incredible things with these kinds of models and techniques. And so we took this labeled data and said, would any other models have performed better? And it turns out that the one that we chose performed the best. It tied with another one called Boosted Decision Tree. But anyways, just to say, there's a lot of really cool tools out there where you can do some really cool stuff if you have the data. So, demo time. So with all my tools, I really love doing animated ASCII art. And I realize this is like heresy of right host and colored stuff, so I apologize, but I made this a separate module, so if you just want to look at ASCII art, then you can just run this. But it just kind of shows a sample command and showing some of the calculations that are performed. And at the end of the day, you can just look at a tutorial of how to use the tool. There's a lot of random fun facts from all the crazy scripts we had to look through. Also, when you're assembling a corpus of almost 500,000 scripts, then you also get to look at other people's ASCII art, which is really cool. Like, I spent an entire weekend like on the stationary bike with my laptop in one hand, just like scrolling through people's ASCII art. Like, yeah, that's cool. I'm going to put that one in the project. I got some weird looks for that. But anyways, a lot of fun stuff in here. Also credits. Again, remember those 28,000 authors? If you are one of those authors, then your name, your handle is actually in this really big array in the script. And you can just randomly go through and say, hey, show me a random 20 authors. And we also have a subset of authors because I looked through all 28,000 of them and thought, that's a really clever name. I want to put that one in this like super elite array. So there's like 300 names in there. So maybe you're one of them. I don't know. Go check it out. But if you actually say, okay, this ASCII art means nothing to me, how do I actually detect evil? I hear you. So, let's say we don't have a directory full of PowerShell scripts. Let's say we have event logs. Well, what we can do is we can parse those event logs, and we can pipe it into get RVO script block. So when you have really big scripts, they can span across well over 100 different script block entries, the 4104 events. So what this will do is it'll go through and it will basically reassemble all the script block events into actual scripts and return them all as PowerShell objects so that you can query remotely or across a lot of systems, or if you have a central repository of all these event logs, you can just query them out and then reassemble scripts out of that. Now, as you can see, once we have all these scripts, we can then pipe it into the main function, which is measure RVO obfuscation. And there we go. Each one of those is taking the script, extracting 5,000 features, measuring those 5,000 features, deciding are you obfuscated or not, printing it out because we used the verbose flag. And as you can see, it has all the script contents. In this case, it was using all the special character obfuscation, the obfuscated true or not. It has the check time, the measure time, and it has all 5,000 script features there. So all the data is there. It's all in PowerShell objects, and we try to make it as easy as possible to kind of point to a directory, to point to event log files, to just pipe it in the pipeline, any way that you have data that you want to say, does this model say this is obfuscated or not? And we try to make it as usable as possible. And I will tell you, again, writing this with Lee, I learned so much about pipelines and parameter bindings. It was really, really cool, and it definitely gives me a huge respect for like the official PowerShellers in this room, because like I write PowerShell that's like, you saw, this is my PowerShell, look at this. Like, again, Script Analyzer would hate me, but I'm doing it because attackers don't care about style. They care about evading detections. And so we have to think in really weird ways to figure out what can they do, what are they doing, and how can we get better at detecting it. And Lee and I made this tool so that other people wouldn't have to spend as many months as we did on this, but they could start with all the data, they could start with all these techniques and start using it right away. Another thing we did is we added, we try to make whitelisting as simple as possible. So again, if in your environment you run this and you have 20 scripts that come back and you look through all of them and say, you know what, I understand this is actually weird syntax here, but this is actually legitimate. You can just drag those into a whitelist folder, it will whitelist them by hash. You can also add content or regex to whitelist them, or you can pass in all these on the command line just for kind of point in time whitelisting. But again, we wanted it to be operational. We didn't release this just for researchers to do researchy stuff. Like, we actually want defenders in their organizations to be able to take this, download it from day one, and use it. Because when people release offensive tools, attackers get to use it from day one, but defenders are like, where do I even start? With this, here's where you can start. So here's a few references to some of the projects that I mentioned before. Also, I can't recommend this blog enough. PowerShell Hearts the Blue Team. We share this with all of our clients. It's just an amazing white paper, really, of all the really cool security-related features that are built into PowerShell. It's far more than just logging, like GIA, constrained language mode. There's just so much awesome stuff that like the community has put together. It's really, really cool. If you want to use Revoke-Obfuscation, it's on my GitHub here, or it's also in the PowerShell gallery. So you can just type install module, revoke-obfuscation, and start detecting obfuscated PowerShell code in just seconds. And if you look at the tutorial in the README, in this project there's a samples, a demos folder as well that contains a few event logs and some scripts that I've generated that are obfuscated. So you can start using it right away and just follow the README and start to see some of this stuff. Also, if you don't like the sound of my voice and just want to read this, then you can just read the white paper that Lee and I did as well, and it has all this information. It has less memes because it's a white paper, but all the information's there. Oh, come on. Made it almost to the end before it started acting up. I'm about to just do this. So in summary, PowerShell obfuscation is being used by attackers. Maybe because I released the framework, they're using it more, but they were already doing it before, I promise. And they're being successful in a lot of different ways at evading detections. But as defenders, in the past 2 years, it's been really cool to see not only my organization's detections, but Microsoft's detections, other competitors in the industry, and defenders and organizations being able to detect more obfuscation. It's really cool, and it's forcing attackers to have to think differently about their old tricks. Science can help. Math can help. At the end of the day, you still need people to think critically about what's the data that we're gathering. How do we label this? I mean, it really takes the community effort. Again, all those scripts that we gathered, like, we couldn't just go write 400,000 scripts. Like, to be able to leverage relationships in the community to gather that data was really cool. And the fact that it was so easy to use the abstract syntax tree. Like, the coolest part about this conference, and this is my first time here, is like, people will be like, oh yeah, script analyzer, like, that's the guy who wrote it over there. It's like, wait, what? Like, I never knew how many of the things I rely on every day were written by, like, the community, and it's so awesome. Another point in the summary, configure PowerShell logging. We tell our clients this all the time, but it really is helpful. And then do something with these logs, like aggregate the logs, centralize them, and if you can do nothing else, run Revoke-Obfuscation on it. See what happens. And again, you can run this on PowerShell scripts, command line arguments, you can point it to event logs, etc. And with that, I would just like to say, thank you very much for letting me be here and for coming and listening. And before I ask for questions, I just want to say thank you for everything that you've taught me so far in this day. And this is the 4-day conference is so cool. Like, I'm giddy about the stuff I'm going to learn the rest of today and the next few days. So thank you very much for your time and attention.